Where we're going to stimulate. Transcranial magnetic stimulation generates a, it'd probably be easier if I showed you what one of these coils look like. Let's see here. Here's one. So this is an air-cooled one. The one in the other room that we'll use for demo is not air-cooled. This one's air-cooled because if you use it repetitively for long durations, it gets very hot, and so we have to pump air through it just to keep it cool. But basically, we're going to hook this thing up to a couple capacitors that are very high-powered. And what it'll do is, when you press the trigger, it will fire an electrical pulse that will circle around through this figure-8 coil. That's why we call it a figure-8 coil or a butterfly coil. And that electrical current will only last for just millionths of a second. It's very, very, very short. Very short electrical impulse. And now what that does is, well, if we want to stimulate neural activity, this thing uses the idea of electromagnetic induction. What that means is that anytime you have a current, there's a magnetic field that surrounds it. So if my finger was the current, there's a magnetic field that surrounds it. And if this current just pulses, that means the magnetic field pulses. It's on and then it's off.
Is that the same as induction cooking?
Similar ideas. And so the point is, whenever you have a changing magnetic field that passes through a conductor, you induce a current. So that's the idea of electromagnetic induction. So if I were to let the magnetic field go on and off inside my brain, it induces a current. Right? The magnetic field will go right through your head. And if it changes, if that magnetic field goes stronger and then weaker, it induces a current. And so if you make that magnetic field strong enough, it'll induce a current that is strong enough to actually cause neurons to fire. And so with the right intensity and depending on the frequency of stimulation,